Hi everyone, Carl from Hyrel, and we're going to go through the actual installation setup of the Milt electrowriting designer kit, experimenter's kit, which we've developed. It's developed to work specifically with our printer. However, those of you that are creative could probably adapt this to a Prusa or one of the other printers, and feel free to do that. So we would be happy to help you with that process if you want to do it. Let me just walk you through real quick. We have a print head here that's designed to heat up and precision dispense a material. Normally the most popular one's PCL, polycaprolactone, and different needles can be used. In this particular case, this needle is probably not the perfect one. The perfect one would be a shorter nozzle. We use that because sometimes we use a second heater, so we have two-zone heating. The second zone is the nozzle only. And we do that so that we can either peak up, raise the temperature just at the exit of the material so that it's thinner and able to pull better. Whereas if you heat the bulk up, sometimes you get degradation if it stays and cooks for hours and hours. Okay, so head, that's for dispensing the material. This is a high voltage power supply, and its whole job is to create an electric field between 5 and 10,000 volts at a low current, so you don't die if you touch it, and between the head and the build plate. So this is an isolated build plate right here, and this would mount on your printer. So what we're going to do is quickly and easily walk through setting this up. So you've received your discovery kit, and now you need to remove the build plate. So I've done that. We include 4 peak screws. These are M5 by 30 millimeter, I believe, and these are predefined holes based on our KR33 Precision X arms that we use. They're made by THK America. They're incredibly precise down to the micron level, and a little expensive, but for precision, which you're going to want if you're doing this type of work, it's hard to beat it. Okay, so you can see the screws protrude about 8 millimeters. And in our case, they will go right on top of our precision standoffs. These are machined so that we're extremely level, and that helps us a lot because we're, let's see if I can get down here and put the first one in. Usually the first one's the hardest one. There we go, we started that. And whoops, got to get to the right hole first. There we go. Now always start your screws before you tighten them down. That way you have more adjustment to it. That's just an old mechanics trick. Notice I'm also just using 2 fingers to spin this. I'm not cranking on this because it's plastic screws. These screws are PEEK. PEEK is very, very strong for a plastic. It's also very stable at elevated temperatures. The glass transition of PEEK is around 160 degrees centigrade, maybe a little bit more, not much more. And so it's stable in any of the print temperatures that we would use. There we go. Now you see it's firmly attached to the printer. And now the first thing we do before we hook anything else up is we're going to home the printer. And the reason for that is we just want to make sure that we haven't adjusted it or mounted it wrong. If you did, it could possibly collide with the rear of the printer, and we don't want that. We don't want the spine to collide with this. You'll see that right now there's a little bit of room back here between the bearing and this, so we can freely move that left, no collisions. And I'm going to go back to home here. All right, now the next thing I will do is, while it's in place, is I'm going to make sure I can home my Z-axis. And home Z. Have to look at the correct button. Sorry, I wasn't wearing my glasses there. Okay, and now that we got that far, before we even plug in the hot plate, there's a switch in the back. I'm flipping the switch up, and now we should see the display come on. And you'll notice that it's turned off, and The battery is now registering, and the temperature is not registering because the hot plate is not plugged in. Now let me show you the hot plate. The hot plate has a precision RTD mounted to it. Okay, and that is your temperature sensor, and we thought it was great to surface mount it to the aluminum circuit board that is our hot plate. Now this is good up to about 80 degrees safely. If you go above that, then you can actually achieve a little bit more than that, but you don't get the best results. You can get a little warping, things like that. So we recommend 80 degrees C maximum. All right, you'll see there's a header here, and there's a header on the bottom. I'm going to turn off this because I don't like to short it. I'm going to come over here and line my pins up. And sometimes you need a flashlight to do a good job with this. In our room, the lighting's not the best. Well, let's see if I can get that. There we go. Now it's in. It's all the way down. If your bed floats a little bit, there are places here to put M3 screws with a washer to lock it down on both sides of it. You'll see 2 here and 2 here. I'll let you do that at your discretion. I'm turning it back on now, and let it power up. Now there is a Bluetooth link from here to Repetrel on new experimental versions of Repetrel. You can download that version of Repetrel if you want to at surferbuddy.org /downloads. Check out that website for the latest beta versions of our Repetrel. That's the software that runs on your PC tablet. Okay, so now we're plugged in, and we're now going to see that the temperature, well, the temperature on this one's not reading correctly, which means we just turned it on. We'll have to go check and see why that is. This is a brand new unit, so normally you would turn it on, and then it would start heating. I'm going to leave it off for the moment. That's how that hooks up. I'll go through the rest of the hookup procedure, and then we'll follow up with one that's working properly. Anyway, now we're going to take the head right here, and we will go ahead and plug that in. And I usually use slot 2 or 3 when I'm doing this type of printing. So I'm going to use slot 2 today. And then I tighten up the set screw, the thumb screw in the back. All right. And right here is usually where we tie in the high voltage. Another place we can do the high voltage is to put the stud in the plastic here and have a star washer that bites into the top of this. That serves 2 purposes. It locks this down and brings the high voltage in from the outside. Here is your power supply, which we conveniently place near the printer, usually on the table next to it, somewhere where we can have easy access to the rear or the front of it for programming. And you have 2 specific cables you want to hook up. One of my favorite places to hook the ground, which is the first thing I always hook up, that would be the green and white wire, is to the yoke. Because this is where we want to make sure that we've got this solidly done. And you can take the front screw out. We are probably going to need, we will need a washer for the final installation, so I will use this over on its side for this moment. And I usually take and bring that up around like that so this can go up and down pretty freely. Fortunately, the bed does almost all the motion. The up and down is just a little bit. That's plugged in. And now we're going to come around and we're going to tie in the high voltage onto the print center. Now that we've hooked up the high voltage to the plate and we have the ground wire to the yoke, which is going to keep the head grounded, we can now plug in the power supply. And we supply an English version of the power supply. This is made by Tesla Man in China. And you go through a procedure on this one. So the first thing you want to do is set it. And we're going to set it to down. There we go. Now you can see the voltage over here is going up. And actually, I believe that's the current. That's milliamps, that's kilovolts. So that's kilovolts. Okay, now at that point, if you hit this button, you'll see that the kilovolts are up at 4.2 kilovolts. You can turn this up and down in real time now that the output's there. And there is actually voltage on here.